Hi guys, it's Ms. Griffin. We're looking at Unit 11, Skill 5. So we're going to move away from the probability part of this unit and move into statistics. So we're going to start with our essential question. How do we describe distributions of data, and how do we use z-scores with normal distribution? So pause your video so you can write this essential question down. This is what we're going to answer as we go through these notes today. So we're going to look at different sample distributions. When we plot data, we can get a distribution. There's a variety of options for distributions, with some of them shown below. So looking at this first one, we're going to call this symmetric. And you can imagine that we are calling it symmetric because the one side looks like the other, right? Woo! This might be something like people's heights. We have very short people, we have medium-sized people, and then we have really tall people. Well, we have very few really tall people. Those are the guys on this end. We have very few really short people. Those are like the 4'10"ers. And then we've got these people in the middle that are your typical like 5'3" to 5'7" or 5'9", depending on who you're talking about here. So we've got low numbers on the side, low numbers on the side, and then quite a bit of the population here in the middle. So that's symmetric. Number 2 is bimodal. Ooh, spelled that wrong. Bimodal. Which means that we have like two different heights here going on. We've got this, and then we've got this. So an example of this would be something like the heights of people in a choir. So say we're talking girls over here, guys over here, you're going to have, again, very few short people, very few tall people, and then most of your population's here sitting in the middle at that average height. Another thing might be like the price of paperback books on Amazon under $30 versus hardcover books. So again, you have two like peaks here essentially. Number 3, we've got something called skewed right. This is one that comes up. Okay, so you got to know it. Notice this curve, tail to the right means skewed right. So something might look like housing costs. So you could have houses that are often about $100,000 in a particular area, and then you could have a few that are like $250,000 or more, right? So you have a lot that are in one range of numbers, and then you have very few in this upper range. The alternative to that would be this one, skewed left. So in this case, the tail goes left, therefore it's skewed left. So this might be something like retirement age. When you retire, you're probably not going to be 25 years old. We've got a few people that might retire at 25, but we've got a ton of people that are going to retire in their 60s. Okay, so retirement age. Example number 5 is a combination of 1 and 2. It's symmetric and bimodal. Symmetric and bimodal. So this might be something like peak restaurant hour. So a restaurant might get a lot of people during the lunch hour and during the dinner hour, but they're not going to have that many people in the in-between. Like that 3 o'clock, 4 o'clock time frame, not many people sitting in the restaurant, right? Number 6, last one. This one is called uniform. It's called uniform because it's pretty much all the same, right? So something like this might be like serial numbers, not cereal that you eat, but cereal like this. Numbers on randomly selected dollar bills, right? You might have some that are the number 1, 4, 5, 6, 7, 8, 9, and then you might have the same amount that are 1, 2, 4, 8, 9, 5, right? Who knows what the numbers actually are, but this is just one example where you're pretty much going to get the same number of serial numbers that are randomly selected on dollar bills. Okay, or another example is like the number that comes up on a die after a roll. So you could get the numbers 1 through 6 on that die when you roll it, and then you'll probably get the same number of 1s as you would get when you roll and you get 5s. Okay? So those are various distributions that you could have. Now there's one that we're going to talk about that's related to this whole standard deviation thing. Standard deviation shows how much variation, dispersion, spread, or scatter from the mean that exists. Remember that the mean is the average, okay? And standard deviation represents a typical deviation from the mean. So it's like everybody is often that 5'5", 5'5" height, but then we might have some people that are on those tail ends with the 4'10" and the 6 foot people, and we want to know how many standard deviations they are from the mean. How much do those numbers deviate from that mean of, say, 5'5"? A low standard deviation indicates that the points tend to be very, very close to one another, close to the mean, actually. And a high standard deviation indicates that the points are spread out over a large range of values. For example, we've got 3 students that we're looking at their last 3 test scores as follows. So student A got all 80s. Student B had 60, 80, 100, and student C had 70, 80, 90. So the mean for each one is an 80. Remember, mean means average. And to find the average, you do x plus x plus x over, in this case, 3. So 80 plus 80 plus 80 over 3 gives us 80. 60 plus 80 plus 100 over 3 gives us 80, excuse me. So student A is consistent, meaning he will deviate little to none, in this case it's none, from the mean, because the mean, again, is 80. Student B has a very wide spread of scores, meaning he deviates quite a bit from the mean. He goes from 60 to 80 to 100. The mean is 80. Happens to be that he got a score of 80 as well, but he is 20 from the mean right here and 20 from the mean right here. So he deviates a lot, meaning his standard deviation is bigger than that of student C, who has a moderate spread, meaning he's moderately deviating from the mean. He's only 10 away from the mean and 10 away from the mean, and then, of course, that 80 is right on the mean. So student B would have the largest standard deviation because he deviates the most from the mean. All right, flip to the next page. So here we're looking at something called normal distribution. When we look at standardized tests such as Regents tests or the SATs, ACTs, most results fall in a normal distribution. They often look like this bell-shaped curve. If you can imagine a bell that a teacher might ring, wow, that's a horrible bell. I should probably find you a picture that looks better than that. All right, here we go. This is what I meant to draw you. So the bell-shaped curve looks like a bell because, if I can draw on it, we've got that shape going on where it comes up in the middle and then the tail ends, okay? So bell-shaped curve is normal distribution. So in this particular case, we have a lot of people that are scoring between 60 and 90, for example, but very few that are on the tail ends of 10 and 140. So we can also talk about standard deviations on a normal curve as well. So on a normal curve, or that bell-shaped curve with normal distribution, we have the mean right in the middle. So the mean goes here, which is 0 standard deviations from the mean. SD, by the way, means standard deviation. And then we can go 1 standard deviation to the right and 1 standard deviation to the left. You will find 68% of your data in between 1 standard deviation from the mean. Okay, these numbers are going to be super critical for you to remember. So start memorizing them. 1 standard deviation, 68% of your data lies within that area. So that's this space here underneath the curve. Then if I go out 2 standard deviations, 1 to the right, 1 to the left, 1 additional, I should say. 2 standard deviations gives us 95% of the data. Okay, so that's including all of this area. 95% of our data is within 2 standard deviations from the mean. And then last but not least, we typically can go up to 3 standard deviations away. 3 standard deviations away gives us 99% of the data. That's a whole lot of data, but there's still that 1% that doesn't get accounted for within 3 standard deviations, because sometimes you might have an outlier that's out here close to 4 or 5 or 10 standard deviations away. Okay? So again, these numbers critical for you to memorize. And I'm going to maybe box them in or highlight them. and then how many standard deviations from the mean. Okay, so we're going to use this information and apply it on the next page. So it says, given the data set of scores on the math section of the SAT that follow the normal curve, the mean is 500 and it has a standard deviation of 100. So I'm going to put some scores right on this bell curve right here. So these 0, 1, -1 are standard deviations. 0 standard deviations, 1 standard deviation, 2 standard deviations, 3 standard deviations. Same thing on the left side. 1 standard deviation to the left, 2 standard deviations to the left, and 3 standard deviations to the left. We don't typically talk about it in negatives, except that the fact that the negative means we are below the mean. And again, the mean was 500. I never finished filling that part in. And so then if the standard deviation is 100, that means I add 100 to 500, giving me 600. Add 100 to 600, giving me 7. And we're just counting up by 100s, and then of course counting backwards by 100s. So again, 95% of the data lies within 2 standard deviations, 99% of the data lies within 3 standard deviations, and therefore 68% of the data lies within 1 standard deviation. So first I'm just going to remind myself 1 standard deviation above / below the mean before I answer this question. So I'm looking at 1 standard deviation below and 1 standard deviation above. What range of values contains 68% of the data? So within this region, 68% of the data would be between 400 and 600. Listen, I do not want you to write 400 to 600. This looks like you are trying to tell me that it's equal to -200. Okay, this is not okay. So again, put an and symbol, write the word to, do something besides a minus sign. Okay? So then I've got what range of values would contain 95% of the data? Well, recall that 95% of the data is within 2 standard deviations above and below the mean. This stuff in parentheses is just for us to help ourselves recall or remember how much or how many standard deviations 95% of the data is within. So now I've got to go out to 2 standard deviations. Boom, boom. So 95% of the data is within 2 standard deviations, landing me at the numbers 300 to 700. Okay, so answer here, answer here. Then the question is asked, what percentage of the data has a value of more than 500? So here's 500, smack dab on the mean. If I look to the right of this, so in this space here, how much data would lie to the right of my mean? Well, typically the mean is exactly in the middle. That's what a mean is, the average middle number. And therefore you would have exactly half of your data, which is 50%. The next question says, what can we say about the score of 450 in this set of data? So I'm going to look to see where 450 would lie. It's about here. 450 is very close to the mean, and therefore we're going to say that it is likely to occur. So a score of 450 is likely to occur. So the reason that we say that it's likely to occur is because it's less than 2 standard deviations from the mean. So we're going to write a little note over here off to the side about when we say it's likely to occur and when we say it's not likely to occur. So again, likely means that it's less than 2 standard deviations above or below the mean. And then to say that something is unlikely to occur, this would mean that it's 2 or more standard deviations above or below the mean. So when we look at part E and it says, what can we say about a value of 700 for this set of data? Well, if I look at my options for 700, I can't scroll. At 700, we are right here. Well, 700 is exactly 2 standard deviations from the mean. So this value would be unlikely to occur. And again, this is because it's 2 or more standard deviations from the mean. Now this one happens to be exactly 2, but remember the option is 2 or more means that it's unlikely. Now it's well and dandy to be able to find how many standard deviations away each of these nice numbers are, like 700 or 600, 1 standard deviation above, 2 standard deviations above. But what if we have a number like 620 and I want to know how many standard deviations above or below the mean, right? Well, what we have is a formula called a z-score. This is something that you do have to memorize, so it's important that you write that here, memorize. We're going to ignore this 620 for a minute. But a z-score is found by using the given value. Make sure we write the word given in here. So some given value minus the mean over the standard deviation. So it says here, using the same set of data from above, answer the following. How many standard deviations, so that means we're going to find a z-score, from the mean is a score of 400. So we start by saying z equals our given value, so this is our given value of 400. Take away the mean that was given to us way up above of 500 over the standard deviation of 100. You can type this whole thing into your calculator at once or do it in your head, but this will give us a -1. So what this is saying, yes, this is our answer, but this is saying that 400 is 1 standard deviation below the mean. And the way that I knew that I was below the mean was because of that negative sitting right there. If it were a positive one, then it would be above the mean. So next we're going to see this random score of 520. So I want to figure out, is it likely or unlikely to occur based on this set of statements over here? Less than 2 standard deviations above or below the mean is likely. 2 or more standard deviations above or below the mean is unlikely. It's very rare that it's going to happen. So here we've got our given value of 520 minus 500 over 100. Which then gives us, when we type it in our calculator, a 0.20. So here's our answer. But then we have to decide, is it likely or unlikely? Well, it's very close to the mean. It's only 0.2 standard deviations above the mean. So remember, if it's less than 2 above or below the mean, it's likely to occur. It's going to happen often. And again, a way to see that is by looking. There's lots of data very close to the mean. We're sitting less than 1 standard deviation away right here. There's lots of data points in this space, which means it's likely to occur. It's going to happen more often than not. So this we would say likely. When it says justify your response, all that means is show your math. Okay, justify means show math. Part C says, would a score of 41 be likely or unlikely to occur? Justify your response. So this is our given value. We start with z equals given value 41 minus 500 over 100. Now, I don't know if this was supposed to be 410 or keep it as 41, but we're going to stick with it for now. So if we do this in our calculator, we end up getting a negative 4.59. So this score tells us that we are below the mean by 4.5 standard deviations. Well, if we are 2 or more below the mean, that means that we're going to be unlikely. And I'm going to take you for one more little trip here. Say that this was a 410. Okay, I just want to talk about the difference and how this changes our problem. So now we've got 410 minus 500 over 100. Let's find out if this is likely or unlikely. This ends up giving us negative 0.9. So we're to the left by less than 1 standard deviation. Well, that's clearly less than 2 standard deviations below the mean. And therefore this, if it was supposed to be a 410, is likely to occur. And again, I just want to take you back up to those points on the bell curve. We just said a score of 41. Well, here, 3 standard deviations, we're still at 200. So score 41 is going to land way over here. That's literally where there's little to no data points. Yes, this goes on forever, but there's very little data points over here, so this is going to be unlikely. Whereas 410 falls in this space where there's a lot of data points, and so this is more likely to occur. All right, we've learned lots of things, and I need you to go and write your summary. So I'm going to flip it over and give you a couple suggestions. So for your summary down here, you can talk about, and you can even take up the space up on this back page that's blank. You can talk about your normal distribution and what goes smack dab in the middle. If you're out 1 standard deviation, what percentage is that? If you're out 2, what percentage is that? And if you're out 3, what percentage is that? Okay, you can also talk about z-scores and how you find them, the formula for it, and what those z-scores actually stand for. Remember that stands for the standard deviations from the mean. And last but not least, you should talk about when something is likely to occur versus unlikely. Let us know if you have questions. Have a great day, and we'll see you in class for your practice problems.